Now let's introduce Vmax and initial velocity. At Vmax, all enzymes are in the enzyme substrate complex state. So we have Vmax. We're saying that at Vmax, all enzymes are in the enzyme substrate step. So we have at Vmax, we have K3 ET. The whole of the ES here, is ET. All of the enzymes are involved with the substrate at maximum velocity. So the whole of ES is the total enzyme. So Vmax, we have K3ET, all of this. And then if we make K3 sort of the formula, we have Vmax from here, Vmax over ET. What if we want to use initial velocity? At initial velocity, ES is still ES. It's not the total enzyme. We still have some free enzyme. So ES is just ES and not the total enzyme. So K3ES, and then K3, if you make K3 subject, we'll have V over ES, equation 7. Now because this is K3, this is K3, we can equate them, equating 6 and 7. So V over ES is equal to Vmax over ET, is equal to Vmax over ET. And then we rearrange where we want to make the, we want to keep the velocity on one side and every other on the other side. So we rearrange. Vmax over V will be ET over ES. And then if we substitute equation 8, if we substitute equation 8 in equation 5, which is the equation of Kn, where we have Km ET over ES minus 1, if you remember. Now ET over ES from equation 8 is Vmax over V. So Vmax over V has replaced initial ET over ES. So we have Vmax over V minus 1 substrate concentration outside. If you open this bracket mathematically, S will multiply this and also multiply this. So we have this. Vmax S over V minus S. Now, if we want to make V the subject of this whole arrangement, mathematically, this, we have this, so S will go over to this side, Km plus S. So Vmax S over V equal to Km plus X. Now, Vmax S equal to V, V will go up here and multiply, cross multiply. V multiplies everything here, so Vmax X is V bracket, all of this. And then V is equal to, make V subject, so divide both sides by Km plus S. And so now V, finally, is equal to Vmax over S, Vmax times S, all over Km plus substrate concentration. Now this finally is what we call the Michaelis-Menten equation. You can see systematically by 8 steps we're able to get the, after 8 equation steps, we're able to get the Michaelis-Menten equation. Initial velocity is equal to maximum velocity times substrate concentration divided by Km plus substrate concentration. The Michaelis-Menten equation, finally. And then if you plot initial velocity against substrate, you are going to get the Michaelis-Menten graph, which is a hyperbole, as we see here. Now Km from this graph, if this is the maximum velocity, which is the peak of the graph, now at K, Vmax gives us the hyperbole. So half of that value is half maximum velocity, and that substrate concentration that gives half maximum velocity is what we call the Km. So if you have a Michaelis-Menten graph, the Km is the substrate concentration at half of the maximum velocity of that enzyme catalyzed reaction. Thank you so much for your time. I believe we had a nice time this afternoon looking at the derivation of the Michaelis-Menten equation, its graph, and the assumptions on which that equation is based on. Leave your questions and online, make your comments. If you like what we do here, do well to spread that news, share our work, and keep following and subscribing to our channels. Until I see you again, it's still Dr. Juliet. Bye-bye for now.